All right, copy down this graph, f prime. Or take a picture with your iPad or something and then just look at it later. All right, the first one is figure out all the x values where f has a relative minimum. F has a relative minimum. Okay, relative minimum means that you're going to find a critical point and you're going to figure out that the sign changes so that it's going to be a minimum. Or you can do a f double prime and check the concavity. The concavity has to be concave up. So you can try that too. But either way, figure out what x values that you have a relative minimum. All right, where is the relative minimum?
0.
-4 and 2. Okay, first of all, from this graph, f has a relative minimum. That means f prime has to be 0. So on this graph, check where the points are 0. Okay, we have 4 zeros. So -4, -2, 2, 5. Now check the sign change. On the left of -4 is minus, and then plus, and then minus, plus, minus. Okay, so now what you want to do is just draw the signs down, up, down, up, down. So where is the relative minimum? -4 and 2. Next. This one's kind of easy. Let's go to this one. Find all intervals on the graph where it's concave down and increasing. Concave down and increasing. You're going to either draw two sign charts, or if you have some other clever ways of finding where is it concave down and increasing, give me those intervals. Okay, this is where we were yesterday. If you were not here, this is the graph we were looking at, and we went through first part, finding, I think, the maximum point. Relative minimum. And we are now on the next part, which is trying to figure out where it is concaving down and increasing at the same time. Okay, remember that this graph is a derivative graph of the first derivative. So from this graph, we had to figure out where it's concaving down. Okay, where is it concaving down? That means second derivative is less than 0. And where is it increasing? That means first derivative is greater than 0. So when they say concave down, just immediately think second derivative less than 0. Increasing means where its first derivative is greater than 0. So go ahead and look at this graph. You can do some sign chart if you want. Where is second derivative less than 0 and first derivative greater than 0? All right, concave down and increasing. Well, first of all, it's much easier to just start with increasing because this is the derivative graph, right? It is the graph of this one. So first, where is it increasing? These parts and these parts, just parts that's above the x-axis. Now, from these parts, we need to figure out where is second derivative less than 0. How do you know from this graph second derivative is less than 0? The slope is negative, right? So that is this part and this part. So the interval that is increasing and concaving down is from -3 to -2 and 3 to 5. Good? Okay. Next question. Find the absolute maximum value of f of x over the closed interval -6 to 6. Okay, so this is more of a tricky question. So this question comes up a lot, and we could get tricked on this. First of all, absolute max is not relative max. Absolute max means that you need to check the endpoints just in case the endpoints are actually the highest number of everything instead of just the hill. For example, if you have a function like this, relative max is here, absolute max is here. If they say absolute max, you gotta check endpoints. Are you guys okay? Okay, so from this graph, you need to figure out where do I have a relative max? Okay, so where is the relative max? Minus 2 and 5. So we need to figure out what is minus 2. What number is at minus 2 and what number is at 5. And then we also have to check the endpoints just in case those 2 points are, one of them is the highest. So then we have to check -6 and 6. Okay, so go ahead and figure out which one of those 4 is going to give me the highest number. All right, so what's the value at -2? No, -2. Is it -1? Am I doing something wrong? Okay, sorry. You're probably right. Yeah, -1. Sorry about that. I think I did something wrong. Okay, what's the value at 5? This is like a mostly negative graph, huh? Oh, okay. So 2 minus 2 pi. Oh, yeah. Yes. Okay, -6. -6 has to be 0. 6. 1.5 minus 2 pi. Okay, so the question was, which one's the relative max?
Absolute max.
Yeah, sorry, absolute max.
5. -6.
Huh?
But endpoint. Oh,
yeah, this one. Yeah, this one will be the absolute max. So actually, we're on the endpoint. This graph is mostly negative. The endpoint is actually the absolute max. So make sure you do check the endpoints when they ask for absolute max or absolute min. All right, so let's now go to day 2. We're gonna do the worksheet that I gave you. Okay, all of these questions you need a calculator because they're just very long. The idea is to use a calculator for all these questions anyways. Okay, first one, the rate at which water is processed and stored in a tank at water utility company is modeled by the function R, where R is blah, 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 thousands of gallons per hour. T is measured in hours and 0 to 8. Water flows from the storage tank to the community at a rate modeled by D of T equals something, thousands of gallons per hour for 0 to 8. There are 2,000 gallons of water in the storage tank at time equals 0. How many thousands of gallons of water are processed and stored in the tank during the 8-hour interval? Processed and stored. So check the words processed and stored. That would be the function R. So basically, how much water is processed and stored by the function R within 8 hours? So that should be an easy question. So go ahead and figure that out. Just be familiar with your calculator. Remember that, because this problem has A, B, C, you're going to have to use the function a lot. So you may want to store it in y equals 2. That way you can just recall it later instead of typing it out every single time. Okay, so set up the integral 0 to 8 of r of t dt. So that is 16.576 thousands of gallons. Are you guys okay? Easy? Second one, is the amount of water in the storage tank increasing or decreasing at time 4 hours? Give a reason for your answer. So what are they asking for? Are they asking for the amount or are they asking for the rate?
asking for the rate.
They're asking for the rate. Okay, so remember that the rate is R and D. The integral is the actual gallons of water. So they want to figure out, is the rate increasing or is the rate decreasing at that time? Remember that you're pumping in water and then you are taking water away. So when you put water in, it's going to be a positive number. When the water leaves, it's going to be a negative rate, a negative number. So you are basically looking at R of 4 minus D of 4. So you're taking the two rates and subtracting each other and then checking, is the rate net positive or is it net negative? Okay, again, because you're going to use these functions a lot, please make sure you store it in Y1 and Y2. That way you don't have to retype it in, especially these numbers, you don't want to type it in wrong. All right, so what is the net rate at that time? Any number? 282. Okay, so we always want to give 3 digits. What is the unit? Thousands of gallons.
Per hour.
Yeah, thousands of gallons per hour. So just kind of look at the unit that they give you in the question. The question is it, what does this number mean? Because a lot of times they would ask you to interpret the meaning of your answer. So what does 0.282 thousands of gallons per hour mean? You want to just take special attention to the sign. So what does this mean? It's increasing at 0.282 thousands of gallons per hour at time equals 4 hours. So at that moment, it's increasing. It could be decreasing later at some other time, but at that moment, it's increasing at this rate. Okay? All right, next. At what time t is the amount of water in the storage tank a maximum? Okay, so amount of water in the tank, I'm going to call it 8. Which is R minus, T. R minus D. How much that's going in and how much that's going out. The net is I'm gonna call it 8. When is it a maximum? How do you figure out when is a maximum?
When it goes from positive to negative.
When what goes from positive to negative?
The sign of the rate RT minus DT. You just put that into one function. The sign of the derivative.
Yes, the sign of the derivative. Okay, we want this to first find 0 or undefined so that we can find the critical points. And then we want to check to see if the sign changes from positive to negative. Now, what does this mean? When they want to figure out when is the amount of water a maximum, are they talking about relative maximum or absolute maximum?
Relative. Absolute.
Absolute. When is it the highest ever in this tank? So it's going to be an absolute maximum. Again, that means you need to check endpoints just in case. And please be careful. There is an initial amount of water in this tank. So you need to take that into consideration. It's not the net change. It's you start with 200 gallons. You make sure you always add 200 gallons from at the end of how much you're checking the net. Sorry. You're done or you have a question? Okay. Yes. So I wrote this part wrong. Sorry about that. Okay, amount of water is you start with 200 plus the integral from 0 to t of the change in the rate. Thank you. All right, so where is 0 and undefined? Okay, so first of all, put the endpoints in your sign chart, 0 and 8. The points that gives a 0 are these two. And the sign goes minus, plus, minus. So we are looking for maximum, that is this one. So remember, we got to check endpoints, the relative max. And you got to put it back in the function to figure out what that value is. Oh, I'm sorry, I shouldn't write FA. Okay, so A of 0 is 200, obviously, because you started with 200. A of 7.5899 is about 201.646. And then A of 8 is about 201.473. So this one is the maximum. So at time equals 7.5899 hours, you have the most water in the tank. Okay, we probably won't be able to finish the other one, but let's start it anyways. Okay, the rate at which people enter the Naples Zoo on a given day is modeled by the function E. The rate at which people leave the zoo is modeled by function L. Both E and L are measured by people per hour, and time is measured in hours after 8 a.m. These functions are valid for 0 to 12, the hours during which the zoo is open. At the time t equals 0, there are no people in the zoo. How many people have entered the zoo by 12 p.m.? Easy. So how many people have entered the zoo by 12 p.m.? Just entered. Okay, they're not talking about how many people are in the zoo, just how many people have entered. How many people have entered the zoo by 12 p.m., so that is 0 to 4, integral from 0 to 4 of E of t dt, so about 203. Okay, 20% of those people leaving the zoo will receive a special discount ticket for a return trip to the zoo. How many people have received a discount ticket by 5 p.m., which is t equals 9? Easy. Okay, just look at how many people have left